Hello and a warm welcome back. Sorry I've not posted before this. I've had PC issues, so I've filmed all this about 3 or 4 times before and was editing a video for release on New Year's, and my PC died. Finally gave up the ghost. So I'm afraid this will be a bit brief because I really need to get all this off the bench so that I can get on with other stuff. Where were we? I was testing this 805 big transmitting triode, and we couldn't really get much out of it, and I was a bit puzzled, and the solution was, which I thought was with my test setup. I was using this transformer to provide a negative voltage, and this is just basically a bridge rectifier, couple of big caps and a resistor to form a CRC filter. That's all well and good for providing a negative bias voltage, but that didn't work, and I'll now show you why it didn't work. This was me test setup that I was using. This represents the negative power supply that I was using to bias the grid negatively in regards to the filament or cathode. See this 150 ohm resistor? What was happening is, when you heat the filament up, electrons are boiled off, should I say, and are attracted to the positive voltage on the anode. However, what starts to happen when you run the triode in a positive grid situation, the triode starts to turn into a diode because there's current flowing into or out of the filament depending on which current version you use. What happened was that because the grid was pulling current, it was all being dropped across this 150 ohm resistor, and hence we couldn't get much out of it. I hope that explains that. I hope I didn't go too quick. So I've got rid of that bias supply, and I'm now using my big bench power supply. It only does 0 to 30 volts, 0 to 5 amps, more than enough for our purposes. Still got the big 1000-volt power supply. And if you look down there, look at all these bloody fuses I've been through. I've had a few disasters. For some reason it keeps blowing fuses, and if you bought fuses recently, then you'll be aware that there's quite a few quid's worth or dollars worth there. They ain't bloody cheap. What I've got, this is the positive from our power supply, and this is diode there. That's just to stop a bit of back EMF to protect the power supply, hopefully. And I'm going to keep this really simple, short and sweet, so forgive the brevity of the video. Yeah, there's not really going to be a lot to look at, and nothing really fantastic and dangerous, to be honest. I did have some footage of me blowing up various valves. That was all lost when my PC crashed, and I haven't got the time now to muck about and film that again, so maybe some other time. Anywho, without further ado, let's pop the filament on. Hopefully you should see that. Oh, I've got to be careful what I'm doing here. You should see the filament starting to glow. I've applied filament voltage. Let's pop some anode voltage on. Just pull you back a bit. This is recording the anode voltage. This is recording the anode current. As you see there, it's pulling about 2 milliamps with no anode voltage on it. So that must be because there's electrons boiling off the filament. Anyway, just try and turn this up really gently to stop blowing bloody fuses. So as you can see what we got there, 300 volts. I'll take it to 500. So as you can see we've got 502 volts on the anode or the plate. We've got 0 volts on the control grid, and as you can see we're pulling 24 milliamps. I'm going to have to call the bias voltage, the grid voltage out, just to try and keep everything in shot. That's 5 volts, and as you can see the anode voltage has gone down, basically because now the power supply is under load. If it's having to supply more current, then the voltage goes down. "10 volts on the control grid, and we're pulling 60 milliamps, let's call that. I mean, these figures look really small, but when you actually do the sums and times it by the voltage, and that's supplying quite a bit of power. Right, go on then, you try and do the sums. Where are we? We've got 60 milliamps. Let's make it 100 milliamps, and then that's really easy. That's with 20 volts on the control grid. 500 volts on the anode or the plate. Right, if it was 1 amp it'd be 500 watts. Because it's 0.1 then it's 50 watts. I hope that makes sense. That's pretty basic maths, isn't it? You just take a naught off the end. Shall we increase the anode voltage a bit? $800 volts. I'm just going to reduce the control grid voltage. There we go. I don't want to burn these out. I don't think I would, but you know. Right, I can hear my big isolation transformer complaining a bit. Right, we've got 1 kilovolt on the anode. 125 milliamps. I'll just knock that up briefly to 20. Where are we? 150. And then I'm going to turn that down, and then I'm going to also turn this anode voltage down just to be safe. So where were we? 1000 volts, 150 milliamps, 1000 times 0.1. Yeah, apologies, 1000 times 0.15 is 150 watts. That's pretty good going, isn't it? Right, let's knock that off. And let that voltage bleed off. Just leave the filament on hot. I'll give you a bit of a shot of that. Let's try and get you in a bit. Get you some close-ups. You can see that's really bright, isn't it? But I mean, that's a 30-watt light bulb there in this, you know, essentially, isn't it? 10 times 3.1, well, it's 35 to be honest, but right, that's safe. Now, let me just knock that off. Right. So really nothing spectacular there, really. Only the figures. Nothing went bang. What am I going to do with these 805 triodes? A lot of people build single-ended amplifiers out of them. However, to get these big old transmitting valves that weren't designed to run in Class A. They were designed to run in Class C or Class B. I won't get into that at the moment, but to run these things and to get them to produce like a audio output that is free, well, relatively free of distortion, you really have to run these at high volts. However, what I usually do with my amplifiers, I just like building them and then I sort of lose interest in them. I listen to a bit and then I have to move them on because I haven't got the money to keep throwing at these things and just have loads of amplifiers sitting around. So I get rid of them. I can't in good conscience sell an amplifier even with 800 volts HT. So what am I going to do with these valves? Well, ideally it'd be nice to build a big single-ended amplifier. However, because these run on such a high voltage, and you really have to run them at a high voltage to make sure that what you get is linear, i.e. free from distortion, you have to run them at high voltage. Well, there's no way I'm going to build an amplifier with 2.5 kilovolts. It might be okay just to have, you know, around and just fire up now and again, but because I'm on a limited budget and I'm mainly like just building the amplifiers and then moving them on, selling them, so that I can then get the money to build another one, there's no way I can sell an amplifier with a power supply even at like 800 volts. The damn things are lethal. And then you've got the law involved. So say I sell this amplifier and somebody like a cat or even just anybody gets a bout off that. This is potentially lethal. I'm in two minds whether to keep them and make an amplifier out of them or sell them and use the money then to get some, I don't know, output transformers or whatever and build a different amp. So I think probably what I'll do with these is sell the buggers and move them on to somebody who wants to muck about with that, and then maybe with the money I can, you know, get some output transformers or whatever and build something that's a bit more sane. Right, well, I've waffled on for long enough now. There's lots of things that need doing. There's a few phono amplifier to look at for Ian that needs sorting. There's loads of boxes of components and things, so I need to do a mail bog, and at some point this year I would finally like to get round to winding some output transformers. Thank you very much for watching. Take care of yourself. Ta-ra for now.